welcome to the video for C3.1.5 where we're going to look at ionic equations. So last lesson we looked at chemical equations and we looked at the state symbols. So this is a combination of that and remembering our ionic compounds. So when we dissolve an ionic solid, it splits up into its ions. So if I have NaCl here, which is AQ, so remember AQ means aqueous or dissolved in water, that we can actually represent that as Na+, which is aqueous, and Cl-, which is aqueous. So if I have 2 NaCl, it's important to remember that that gives me 2 Na+, aqueous, and 2 Cl-, which is aqueous. So this means we can simplify our equations into ionic equations. So here's an example of an overall equation that we can simplify into an ionic equation. So this is HCl reacting with lithium hydroxide to give lithium chloride, and all of those are aqueous or dissolved in water, but I also get water, which is a liquid. So this means I can split up HCl, which is aqueous, into H plus aqueous plus Cl minus AQ plus, so this lithium hydroxide can split up into La plus, which is aqueous, and OH minus, which is aqueous, and that gives me Li plus, which is aqueous, plus Cl minus, which is aqueous, and then it gives me my water, which we don't split up because it's an L. So the only thing we split up into its ions are the things that are got AQ in brackets that are ionic. So if I do this, what you'll notice is, so here's my arrow. So if we look to the left of the arrow and to the right of the arrow, we'll notice that some species are the same on both. So I've got Cl minus aqueous on that side, and I've got the same thing on this side. And I've also got lithium plus aqueous on that side, and lithium plus an aqueous on that side. So what that means is that in this reaction, those chemicals are not really doing anything. So those ions are not changing anything. And because they're not doing anything, they're just sat there, we call them spectator ions. And because nothing's changing, that means we can rewrite the equation as ionic equation, which is where we've taken out the spectator ions. So I can remove all of those that have got a circle, I can remove from my ionic equation, because they're the same on the left-hand side as the right-hand side, so nothing is changing. So if I remove those, what I get for this instead, so I write my H plus out, but I ignore these two because they're the same on the left-hand side as right-hand side. Then I add my OH minus, which is aqueous. Then I've got my arrow, and then these two are the same on the left-hand side, so I'll leave those out. And that gives me water as a liquid. So this is my ionic equation. Now, sometimes people think the ionic equation means there's only ions, but it doesn't, because you'll notice the water, which is covalent and a liquid, has not been split up into ions. What it means is that the spectator ions have been removed. Okay, there's some examples for you to have a go at on Teams. Thank you for listening. See you next time.